Right, welcome to sheet 2 of the Further Maths course. Now, on question 1, we're not going to go through all of this because actually all of this is very, very straightforward, and I'll just copy and paste the answers into 1A and similarly for 1B and C. Just to warm yourselves up, you can have, 60 seconds to try and do 1D. Okay, so it's quite simple. We do row times column and multiplying out matrices. So if we do this row times this column, we get 4 times 1 is 4, minus 2 times minus 8 is 16. Add them together, we get 20. 4 times 6 and minus 2 times 5 gives me 24 minus 10, that's 14. 3 times 1 and 1 times minus 8, that gives me minus 5. 3 times 6, 18, and 1 times 5, 3 times 6 is 18, and 1 times 5, that's going to give me 23. Right, let's have a look at the next question. Right, just moving on to compare this with our previous way of doing this question from sheet 1. Have a look at this, and it shows you how they're going to build up the method of differences questions. So I'll give you about 2 minutes to have a go at this. Right, so we're going to simplify this expression. So we know that r times r plus 1 is r squared plus r. And we know that's going to be r squared. And we've got minus r times minus 1 is another plus r. So this will just equal to r. So we can sum from 1 to 30 r brackets r plus 1 minus r times r minus 1, and that will be equal to the sum of 2r from 1 to 30, which equals 2 times the sum from 1 to 30 of r. And we know the formula. This is just going to give me the integers from 1 to formula, and we should know that that's just 2 times n over 2 or times n plus 1, which is just going to be 2 times 30 over 2 times 31. 2's cancel. 30 times 31 is 930, which is exactly the same as we get in sheet 1 question 2. So we just quickly pan back to sheet 1 question 2. I didn't have here we go. So if we pan back to it, we can see it's exactly the same answer and exactly the same question. So summing these up in these two different ways is exactly the same. Right, let's look at the next question. Okay, this shouldn't take very long. I'm just going to give you 60 seconds to have a go at these. It's what you do in the next question with them that's important. Right, so we differentiate e to the x, we just get e to the x. Differentiate e to the 3x, we get 3e to the 3x. And these questions will get much harder as the sheets move on. Dy by dx here is just equal to a half e to the half x. And that's that question done. So it didn't take very long at all. Now bear in mind what we did in this question. See if you can do this question. And I think if you're a further mathematician, you should be able to do it by inspection, which is using what we did in question 3, or by solving the differential equation. You should be able to do both of those in 60 seconds. So do both methods in 60 seconds and see what you get. Okay, so what you hopefully would have noticed that we have dy by dx is equal to 3 times y. And if we go back to the last question, we can see in this one we've got dy by dx is 3 times the y value. So we could just use y equals e to the 3x as a function that will solve this differential equation. Now if we were to solve it generally what you do is you do from your single math stuff, you do integral of y 1 over y dy is equal to the integral of 3 dx, dividing by it and integrating both sides with respect to x. And this will leave us natural log of y is equal to 3x plus c. So y is equal to e to the 3x plus c. And therefore, if we write that as y is equal to e to the 3x times by e to the c, because obviously if we add the indices we can do that, And e to c, we're just going to let equal to a. So therefore, y will equal some multiple of e to the 3x. Sorry, I've written that wrong. I've written the e twice. Let's just do that again. So e to the 3x. And we can see that the one we had does form in the pattern where a is equal to 1. There's two different ways that you do that question, bearing in mind the question we just done. Right, so the next question. Okay, nice easy volumes question to get you warmed up before we do volumes of revolution and integration that way, and seeing how we can make it easier for you to remember the formula by actually thinking about what it means in terms of volumes. So I'm going to give you an extra 60 seconds to finish off this question. Right, so what we have is we have this being rotated around this axis to form two cylinders effectively. You've got one cylinder radius 4, height 2, and another cylinder radius 2, height 5. So the volume of this one's going to be 2 times by pi times 4 squared, so pi r squared times the height, plus this one, which is going to be the height of 3, because the whole thing was 5. So we're going to get 3 times pi times 2 squared. Nice easy stuff, almost GCSE level really. 1632 pi plus 412 pi to get 44 pi. Right, now we're going to get on to a couple of questions where you actually think a little bit on the third maths side, and it's probably starting to give you some decent revision. So, next question. Right, didn't click on it. Clicking on the wrong thing. Try again. Eventually I get the next question. There we go. Right, I'm going to give you a good 3 minutes to have a go at this question. Just try and identify which of the linear transformations first, and then work on doing the transformations. It's not important if you don't finish all those in the 3 minutes, but it's important you identify which of these are linear transformations. Right, so what you should realise, if we're looking for a linear transformation, we know that it's a linear transformation if both of them are of the form ax plus by. So we can clearly see this 3x and 2y are of that form. Y and x is of that form. X squared is not of that form, it's not linear, so therefore that's not going to work. Y and minus x are of that form, and then this one is not, because you've got a plus minus a constant on the end. So this one is not a linear transformation. So the three linear transformations are A, B, C, and D. A, B, and D, and C and E are not linear transformations. And if you manage to get through all the images, you should have got 3, 2, 9, 2, I think. I'm trying to read out my own answers. 9, 2, oh no, I've done 9, 2, 9, 6, 3, 6. And we've got B dash will be 5 in, so you swap them around to 3, 5, 4, 7, and 5, 6. C dash would equal 0, 0, 0, 1, 1, 0, 1, and sorry, I'm just going to check my handwriting. 1, so it's going to be 1 minus 1. Sorry, I did some answers already, but I just couldn't read my own writing there. So for D, we get 0, 0, 1, 0, 1 minus 1, 0, 1. And for E dash, we get minus 1, 0, 0, 1, 2, 2, and 1, 1. I just want to check that one again, because again my writing's a bit wobbly on that one, so I'm putting 1 and I get, yeah, I was right there, so it's going to give you, no, 2 minus 1's 1, yeah, that's good, and put that in and get 1, so that's correct. Okay, so that's question 6. All right, moving on to question 7. Right, see if you can do this without looking in any books or formula sheets. Can you remember the Maclaurin's expansion for these three? If you're getting good and ready for your exam, you should be able to do these three expansions in your head and know them off by heart. So see if you can do that, and then see if you can spot any sort of patterns going on with them. So I'm going to give you 60 seconds just to try and write those three out, or at least have a guess. If you don't know what it is, just guess and see how close you get. Right, so if we do e to the x first, and e to the x equals 1 plus x squared over 2 plus x cubed over 3 factorial plus and so on. And well, actually, I'll go a little bit further. I'm going to get x to the 4 over 24. It's 4 factorial, x to the 5 over 120. Probably for argument's sake, I should put over 6 for this one. And then if we do cos x, so cos x will equal 1 minus x squared over 2 plus x to the 4 over 24. And sine x is equal to x minus x cubed over 6 plus x to the 5 over 120. And what you should hopefully notice is there's a pattern going on here with the coefficients. Oops, undo that one. Different color. We get x cubed over 6, x cubed over 6, x5 over... And you can see a pattern involving cos x and sin x. And if you think about what you know about e to the I theta and cos theta plus I sine theta, you will begin to realize the connection that's going on here and why we've done this question on this sheet, and it's building up to things in the future sheets. And obviously sheets 1 and 2 have been very easy. You'll soon find by about sheet 4 things will step up a little bit. Anyway, that's the end of today's stream. Sheet 3 on Thursday, exactly the same time.